All right, good afternoon. Today we are continuing our series for the NFL Big Data Bowl. The theme for this year is using the pre-snap information to try and make post-snap predictions. If you've seen the other parts of my series on this, we've just been doing data exploration to get a better idea of how we could go about doing this pre and post-snap prediction. It's very open-ended this year in terms of the competition. There are 3 tracks that you can enter. One is the undergraduate track, which I'm not an undergraduate, so we can't do that. One is the metric track, which is like just a general talk about the numbers that you're seeing, try and do some type of prediction, whether it's on the play, the scheme, or the player. And then the third is the coaching track, which is you will kind of put together a presentation with a coaching staff as your audience. The idea here is that you would present these not from the technical perspective, but from I almost want to call it like the business perspective, like addressing your audience directly and not going into a lot of the technical details in terms of what you did, but more of what answers the questions or the predictions that you're trying to make, and how is that information actually going to be useful. They give some examples here, and this is just like very basic, a good place for you to start. So can you predict run versus pass? Can you predict the from the scheme, are they going to be blitzing? What are the different route combinations that you're having? And then even for an individual player, what are their blocking assignments or pass patterns, things like that. And it says here to be creative with your submissions. So you want to think about, in terms of a final output for this, who is your ideal audience for this? If you're going to be presenting to a team, you want to have a very probably specific team or a set of coaches in mind to go ahead and put this against or present this to, so that way you can help them prepare against who they're going to go up against in the following week. We started by just pulling in the data, doing some basic data exploration. We went through each table one by one, just checking for null data, and there's very little overall in the data set, which means it's a very curated or very well curated set of information that we've got here. Things like the yard line side, when this doesn't actually have information, it's because they're at midfield. So there's no information. It doesn't. It's not like one team versus another in terms of the side. And then, for example, the offensive formation or receiver alignments, these are kicking plays, in which case there is no offensive formation, so like the kickoffs, and no alignment for those. Play clock at snap, only one didn't have a piece of information. Not really a big deal. We didn't look into this particular one, but not too surprising. We did have a number here of past results that didn't have any value in, and it's because these are run plays. So when there's a run, there's not going to be anything in the pass result information here. So just kind of give you an idea of how we've looked at this in the past to get an idea of the data overall. And then this is like a merged in data set from Pro Football Focus on adding a whole bunch of information here and just kind of giving more information that we can use. And that's going to become more important when you try and think of route combinations and things like that on the offensive or defensive plays here. So then we started to just look at high level some of the summary statistics to get an idea here. When we pulled in the player play table, which actually has the rushing yards on the play here, we thought, well, this is insanely low. No team would run a play if they were only going to get 0.08 yards. And it turns out that's part of the reason why these are mostly full, is that there are zeros here. And those zeros, for example, if it's not a rushing play, of course, there will be no rush yards, which then dramatically brings down the mean for those, because those will always be zero. And then the same thing is true for receiving. So then we found that there's already a binary field in there that is the had rush attempt. So if it's 1, then they attempted the rush. And then what does the rushing yards look like that? And then that looks like a much healthier number. You're talking on average when they ran the ball, it's 4.5 yards. So theoretically, or I guess on average, you expected a first down every 3 downs, assuming everything went perfectly and you ran the ball every time. The problem is the defense is going to key in that you're only going to run the ball, and they'll start to stack defenders in the box to bring down your rushing yards per attempt. And the same thing here for the pass reception. So this is not a passing attempt. These are just in the plays where a player caught the ball. On average, how many yards did they get? And it's almost 11 yards per play when they have reception. So if you have a quarterback that's completing 50% of their passes, every 2 to 3 downs, you're going to be getting a first down on average. But again, we know that's not the case. And so then we started to break them down team by team to get an idea of who's doing better in certain aspects of their offenses. So we did grouping here by the team's abbreviation. The same information, just they ran the ball almost to get an idea who's the most effective at this. So when they run the ball, who's getting the most yards per play? And it turns out Chicago, Las Vegas, Seattle, Jacksonville, and Baltimore were all leaders here. And then similarly, we did the same thing for the bottom teams. So instead of going from the top, we're going from the bottom. And then we had Tampa Bay, Los Angeles, Indianapolis, Cincinnati, and Denver. So we did the same thing for passing, and we got the tops and the bottoms. And then we did some work to go ahead and try to aggregate more information into the data set. We were only looking purely at the player plays, which for a individual will only have an ID. It won't have their name. So we tried to bring that in. So we grouped them by their ID. One was the average per play result, and then one was the count of those plays. We did the same thing for rushing and passing. And we combine this into a final table here, which is the yardage data. And this has the player's name, that's the display name here, and the formation that the offense was in. So with this, we've connected most of the tables in the data set together, and we can use this to quickly add fields to the other parts. And that's why today I wanted to start getting into some of the basic predictions, because we can quickly add or remove fields. Right now, we've got a very bare bones data set that is highly populated. So we should start to get an idea of what things are correlated, how well can we do prediction-wise, and then are there things that we can add in to get more of that predictive power or decide on what we want to have the outcome be, right? And after that, we went into the different teams a little bit more now that we could push or pull those together. First we were going through the formations, and then we were going by combinations of formations and teams. So if you're looking here, on average in the NFL, we already knew the average for a run was about 4.5 yards. When you're running out of the empty backfield situation, you're actually getting significantly more yards than the average. For the shotgun, you were getting slightly more than average, and everything else was about or below average. But these aren't always run in the same proportions, and so we looked at the counts of these here. So you'll see the reason why the offenses were highly effective in those empty backfield sets when they were doing the rushes is because it didn't happen that frequently. You're getting 6.5 yards, but out of the, 6,000 plays or so across the season, you're only seeing it 95 times over the course of the season. Not too likely of an outcome, but then you have a formation here like the Wildcat, which is where the running back lines up and the quarterback and the receivers usually wide out. You will then see here, well, they only did it 74 times, but it was less effective as a play, like even worse than average. So the reason for that is because the threat of a pass is significantly reduced here once you have a running back in the quarterback position. And so defenses then started to move up, and that means that they can get to the ball quicker on those runs plays. And of course, you're going to then have a less likely outcome. The most common formations across the season were the shotgun and the single back set. Shotgun means that the quarterback is away from the center and backed up. You can have multiple running backs in the backfield, even on a shotgun play. And then The single back is the quarterback is directly behind the center, like right next to them, and there's only one running back behind the quarterback. So then we did the same thing for receiving. And what we saw here was that single back formation set, far more effective in terms of receiving yards, and the same thing for that I formation. So part of the reason why is that it wasn't happening too frequently on those receiving plays. So for the most part here, it was, I believe it was almost 6,000 passing plays. And the majority of them, over like almost 2/3 of them, were coming from the shotgun formation. So shotgun formation, you're seeing about average outcomes here. And then if you look here, the Wildcat, we saw there were 74 times where it was run, only 10 times where there was pass, and they were getting below average outcomes here. So in general, when you were in the Wildcat formation, it just wasn't effective. And then similarly here in the shotgun formation, you were getting just slightly above average output, but actually one of the best formations to throw from was the single back formation here. And you can see when it's in the running game, it's about even, but then you have a reduced outcome of rush yards or versus pass yards. So there were two effective formations, but usually the opposite expectation would perform slightly better there. And that's likely just because of what the defenses would do. So if you line up in the shotgun formation, you can see here, it's about, I would say it's about 60-40 run versus pass versus look at the single back formation. And you're talking, it's now about 75% of the time they would actually run versus pass. And so if we were making like a very basic model just on the formation alone, make a prediction, you can see here, shotgun becomes harder to predict, right? Because there are just more cases where they ran versus passed versus something like a single back or even these empty versus Wildcat formations where you're way more expecting a certain outcome, right? We saw was empty formations less than 10% of the time was run. Wildcat, same thing. It's like, 80% of the time you're going to run the ball versus throw. So that's just what the defenses would key in on. Now, very basic, but we can see that play out even in these numbers. And then I tried to look at specific teams here and get an idea of how well they're doing. I originally started out with Arizona, and they had a below average offensive season. So there wasn't a whole lot here to predict or to really look in, but I keyed in on Tampa because they had a very, very low average in terms of their run plays. And so I was curious, were they that much more effective in terms of receiving? And this was just to prove out that we could do the formation and player situation. So if a certain player was on the field for a formation, was it more likely to be a tip-off of what they were going to do? And so there were just certain situations where, for example, here, Cole Beasley was only getting a reception on shotgun plays. So if he was in on a single back formation, would he, be somebody you really have to be worried about as a defense? Or was he even on the field for the single back, right? We don't have visibility into that, but it's something to keep in mind. And then the same thing for these other ones here. Leonard Fournette's running back. Mike Evans is in pretty frequently. That we get kind of those looks. And then here we put receiving yards right next to the rushing yards for the average outcome here based on the formation and the game. And the way this could be enhanced is if I also put in the count of the plays where these had actually happened. So if you look here in this first game, they were in the I formation 9 times. They ran the ball 8 times out of those. Single back, very similar. They're mostly running from those plays. And then shotgun, they're split a little more evenly. But for the most part, they're not going to pass if they're not in shotgun formation. It's really, over the course of the game, if you're talking, these were just the completions, not the pass attempts, which is something we would have to do to enhance the data set. There really wasn't many situations where you would need to be particularly concerned about passing if it was not the shotgun formation. There's a few here to try and keep you honest, but for the most part, you know to key in on that. Same thing here. This game, you're talking there's 13 rush attempts the whole game. Most of it's in the shotgun in terms of their formation, and then they're just throwing the ball the whole time. This game became even more unbalanced. So you're talking shotgun. They threw 31 times. They only ran once. And so it was an interesting dichotomy in terms of their numbers, especially in the run versus pass, where you can see kind of over and over again per game. If you're looking, shotgun formation is the majority of where they are throwing passes from. And so if you wanted to build a predictive model for Tampa Bay for run versus pass, if you put in the formation, you're going to see it's going to have huge weight on the outcome of the play. Because if you're saying shotgun, if you predict pass, what is it, 75, 80% of the time, you'll be correct no matter what else you do. That, you know, can you, it's very good for a base model, and then can you start to pull out the situations where they run? And so another enhancement we could do to the data set here would be to include there's like a receiver formation where you can tell there's like bunch, trips, 1-1, 1-2, just kind of tells you the balance of where your players are on the field. So if you have, can I do paint? Yes. Okay. Oh, but that puts it on the other screen. Okay. Well, we'll do this. So can you see the mouse here? Okay. You have your alignment here. I'm just going to quickly draw in the X's for those. And then the different formations, you can have one receiver over here, one receiver over here, right? You've got your QB. And then let's say you have a running back, tight end. How many do I have now? 5, 6, 7, 8, 9, 10. And then let's just say there's 2 backs back here, right? You have your 10 players, and then we can go back a little bit. You can have 1 back here. You can have 2 receivers, a receiver over here, and a tight end, right? And that's what they mean by like the receiver groupings. So that way you have an idea of what the plays actually look like. And if we add this information, what we may see is it's more likely that instead of having, and I'm just saying this at random, I don't actually know if this is true, if they were in this 1-2 receiver formation and they had 2 backs in the backfield, that they were, I don't know, 95% likely to run versus actually do a pass. And so those were the keys of if they were in the shotgun and they had 2 backs in the backfield, you knew that they were more likely to run. And that's what I mean by enhancing our data set, adding a little bit more information beyond the base version, just to try and see if we can get more predictive power out of it. So, yeah, this is the other Arizona. So we can work on doing some very basic models here. I've got pandas. I haven't used NumPy yet or SNS, which is great. And then the PyPlot, so we can do output here. All right, so let's, I had a tab with the fields because I do want to add receiver formation. I just need to see which table it's in. Go back up to here. Play data, receiver alignment. So it's in plays. Receiver alignment. and pass results. The reason why we want to add pass result here is that when we get, because right now we only have the pass completion information, we can use the pass result because that includes information about an incomplete pass, sacks, interceptions, things like that. That becomes much more useful information. And then let's see here. Okay, so those add defensive information, tracking data. We're not using yet, which I think is fine. So that should be okay. Let's do this. Oops. Check the chat real quick. Okay. Let's just see my mind. Got it. Okay. So I'll put this in the chat just so you guys can see the same. The data table, or the data page, has the information that is all of the different tables. Oh, I should put in SQL. Does this have it? I hope so. Split the data. This is some of the normalization. There we go. Let's just start with linear models. And because I want to predict run versus pass, I need a logistic regression to keep everything between 0 and 1. And then we need to be able to evaluate our model. So we're going to look at accuracy, classification, and do things that way. So then run this so it's updated. All right. Run this so it's updated. Scroll down here. Where are you? Yeah. So let's do this. Just make logistic regression, predicting run versus pass. We're going to use player play plays and player datasets. So this just gives you an idea of what we're going to do. And then is there, I guess we have to create the play outcome, right? Because right now we don't have it, whether it's run or pass. Well, we can, okay, so we can do this. We can do, let's try and predict whether it's a rush play, right? So we have the rushing attempt equals 1. And so we can do things that way. So we've got cat. I guess I should lay this out better. Categorical variables. And these are, we have like, what was it? Offense formation. Team abbreviation. What was the other one that I just pulled in? I shouldn't have scrolled down as much looking at the fields. Pass results. This is the receiver alignment. What else would be in here? I'm not going to tell it game ID, NFL ID, or play ID. Those aren't useful. With the receiver alignment. Game ID, player ID, receiver yards. So I think that's the essence of it. And the reason why I don't want to include like the rushing yards is that it's going to very much mirror the rush attempt, right? No matter what, rush attempt is going to be 0 or 1. And then if it has rushing yards, it's going to be a rushing play. So I don't want to include that, but I do want to say target add rush attempt. And we want to set this. So what was that play? Was it rush data? Yard data. Categorical variables. y equals yard data target. This, I hope, works. Uh-oh, did this not work? What did I miss? Let's see here. Yard data should have that, or place should have that, and then yard data should incorporate. Right? What did I miss? Okay. Oh, because I think did I set yard data? I did. Okay. We'll do this. Yard, not hard. Yard data. And let's see. So, why isn't that there? I merged those. Right? By. Oh, because I dropped them out here. I need to include this in the level. Now when I go here, dum dum dum. Great. I guess the target. Let's just change this to pass result. Great, but that's not the best outcome here. Right, so I didn't know. Is there a play where pass result is an A? Let's see. Yard data pass result count value counts. So completed pass, incomplete pass, no, because of the way I filtered the data, which is fine. And then the R's are the QB scrambles. Okay. So that's not actual valuable information. All right, let's do this. We want to go yard data. I want to say rush if Let's just do this. So if it's a pass, we're going to call it 0. We'll change this to it's not Russian yards. It's Russian yards. All right, for row in yard. I think it's this way. Can assign why am I not remembering? That. Is it the other way? Hold on. Yeah, I have it backwards. So this comes out. Let's test this. Yard data dot net row 0. Oh, why are there two? Why are there 2 0 indexes? Yeah, why are there 2 indexes? If I say, well, let's fix it. Why are there still 2 zeros? I guess we can do it this way. So I need to do yard data equals yard data dot reset index. And then let's take a look at this. That's returning every row after the first one. What is it? Drop column index. Just drop access by column. Okay, so this go together here. So it's not empty. Let's see. Right, I set volt to 0, so that makes sense. Okay. So then target is rush. Now that we got that sorted out, rush. We should know roughly. I don't think we only had 6,000 plays in our data set. So about 15-ish minutes before I have to go get my kid. So what's happening here? Wait, let's go here. What was it? The way I did the join. So we had the plays. Here. If I just say rush why is there only 400 in the rush done? Is the rusher stats? I'm watching rusher stats. So when this merge happens, receiver alignment is throwing it out. Or pass result, because it's going to be grouped on those. Oh man, okay. So those need to come out. Receiver alignment and the pass result. So we do this. We still want to see that this is Good. Rush. I keep doing the capital there. Data. Great. And then our data should look much. Yes. 12,000 plays over the course of the season sounds right. All right. The play formation is now correct. Call this yard data. Equals pass results, and it was like receiver formation, receiver alignment. I give up trying to spell. It's gonna be a bad day for that today. Okay, and that should be. Well, let's just copy this because it's exactly the same. Cool. Oh, of course it's going to be the same. That is still the same. Great. All right. Still fix all this. Your data enhanced, great. Let's do the value counts. There we go. Much more balanced, as I would expect. So now we can go back to actually building the model here. What do we got? Why is this way? Okay. So our categorical variables are the formation, pass result, receiver, alignment. Right, this is our target. Should I include the numerical is the question. Offense formation. formation, receiving yards, passer rush should be anyway. All right. So I just want this to just be purely categorical for now. So then I want to do splitting the data. Extreme X test Y train. Actually make this smaller because we don't have a lot of data to begin with. And then this should be categoricals. This should be one hot encoding. This log model. The steps for, or the brackets around each step. This one is and all we're trying to do is predict run or pass, close that, log model dot X train log train. Log model dot predict. Give it the test data set. And then, so splitting it, you're telling it to values. Put the data, make the prediction. So model accuracy. Logistic Regression. Did I bring that in correctly up here? I did. Did I just not spell it right? Logistic. So I did spell it correctly, I just didn't do it right. And just it was 100% right all the time. Doesn't seem right. Hold on, what was the target? Rush. It should have predicted. So it's working off the other data set. Okay. Now, why would you always be ready? All right, there's something that's not correct in here. But I'm out of time. Yeah, we'll have to pick up here for next time. We did get together a basic logistic regression model. We did incorporate in the pass result information and the receiver alignment to try and help that. Right now, the basic logistic model is giving 100% accuracy, which does not seem like it is correct. I suppose it has most of the information here, like game ID, play ID, that's going to tell you exactly who it is. Team abbreviation, formation, rush yards, pass result. I guess we can end up with 100% accuracy that way. But still doesn't seem right. I want to dig into this more next time when we come back to this on Monday. The idea here is that, I mean, if I have these, I can always predict the outcome, which seems a little too strong here. So that seems like just way too good. We have 12,000 rows, so I would assume that there's something maybe that I have not done correctly here, or at least I would assume so. And that's why I want to investigate a little bit more. Otherwise, if we're predicting with 100% accuracy when we have this information, that to me is kind of crazy. There's no way it should have that it was always a rush play given the alignment. What information we pass it? We pass it to team, formation. Did I give a pass result? Yes, I did. That's fine. Pass result's going to be really highly correlated with knowing whether it's a pass or not. So, of course, that's going to come back. You know the result of the play. Of course, you're going to be able to predict the play, right? And that's okay. That's much more reasonable. About 70% of the time, we can be right, just based on what the team is, their formation, and their receiver alignment. So not exactly, not the same as 100%, but it makes sense that, yeah, I was including the play result. And so, of course, we were going to get 100% accuracy. And so that makes a bit more sense. So there's more information that we can include here for each of these plays. We can look at adding more information about who the players are in these sets. So that way we have a better idea of the player outcome. So who's the running back, tight end, receivers, even quarterback on the play to get an idea of what the outcome is. So we will need to, I guess, go through the player play data and get a list of, I suppose we could just incorporate the IDs of who it is here on the field for the play to try and see if that will give us more predictive power. And so we can pick that up next time on Monday, where now we've got very basic model, just simple logistic regression predicting run or pass. Then can we extend that? We've got 70% base accuracy. I think that's fine. The point is just to get a bare bones model up today, which we did. And then I want to go and I want to, like I said, figure out how we can incorporate the players that are on the field. So that way we're getting an idea of everything pre-snap that we could, right? We know the formation. We know how the receivers are aligned, but we don't know who those players are yet. And to see if that makes a difference on the play. I mean, if we could, and this is like an ideal world scenario, it's who's under or who is the person receiving the snap on the play to, basically who's behind the center to receive it. Is it going to be the quarterback? Is it going to be the running back? We saw that that happens infrequently during the game. So I don't know that it's like a high priority for us to look to incorporate that. I think we just want to figure out who are the, let's just say the 11 players on the field for the offense and see if we can predict the outcome that way. And see if there are some players with very strong predictive power. Like, if a certain player is on the field, are we likely to know whether it's run versus pass? Right? Those are extremely useful edges for teams to have. So that way you can look at the data and decide that. And I know that was something that Bill Belichick had mentioned that he uses as a strategy. So once they're sure that they've got the game in hand, they will start to call plays just to mess with the opponent's analytics to throw them out of whack. So that way, when they're into a game that really matters, they can then already have a counter ready for it. So let's just say that they had a certain running back in on a play, then they start to on some of these throwaway plays when they've got the game in hand, start to try and counteract the opponent's data by, let's say, having them take like a small run instead of a big run to throw it off. Or they throw out it's a formation that they use rarely, but usually to counteract a big play, they will intentionally run like a weakened version of it just so that they screw with the opponent's analytics, because those plays appear so infrequently that to them then it won't look like an outlier anymore. So keeping that in mind with what we're doing. And so we wanted to see here for next time, adding more player information to our data set, who are the players that are on the field essentially, and then trying to see if that adds predictive power. So that's all for today. Thank you for those who come and watch. We'll be back on Monday with another hopefully longer session like this to go through it. Next week's schedule I will be a little bit different just because it is the Thanksgiving week. So I'll be streaming Monday, Tuesday, Wednesday, which I normally don't stream, and then on Friday. So I'll have a little bit more time on the development front. So Monday we will be working on the the NFL Big Data Bowl Monday and Friday. Tuesday will be an update stream for the Pokemon progress, which I still have running here. And then Wednesday, I'll have another stream in. I'm not sure what exactly the content will be as far as that goes. And then I had recently been invited to try and play a mobile game called Honor of Kings. I'm going to give that a shot for a couple streams, just see how that goes. I had started playing it on my own, having pretty decent results so far. So I'm going to just try something new as far as those go. It should be, I would say, relatively short streams. I'll try that over the weekend to see how that goes. And then we'll see if I can incorporate those going forward as well. So for those of you who came, again, thank you. I appreciate all your guys' support, and I will see you all on Monday.